Assalamu alaikum. I'm Fazlur Rabbi, ID 18369921. Before starting presentation, I would like to thank to our honorable course teacher Nafis Ahmed Sisti sir for giving me opportunity to talking about today's presentation. Our today's presentation topic is a design of a combinational logic circuit. Here is our group members information. Now here is contents. In this presentation, we will discuss about objective, theory, problem statement, apparatus list, experimental procedure, result, simulation, result analysis, discussion, conclusion, and reference. Objective. The main objectives of the experiment are to investigate different logic components of a combinational logic circuit, then the perform analysis of the design circuit, lastly to comment on the limitation of the design circuit. Theory. Logic gates. A logic gate is a component in digital circuits that serves as a building block. They carry out basic logical operations that are essential in digital circuitry. There are 7 basic logic gates: AND, OR, NOT, NOR, NAND, XOR, and XNOR. Different logic operations of different ICs will be introduced, which perform the following. Here is the operation and expression. That was my part of the presentation. Now I would like to invite my another groupmate Tarifuzzaman Ria to continue remaining part of the presentation. Thank you, sir.
Thanks for giving me the floor. I am Tarifuzzaman Riyad. Now I am going to talk about the basic logic gate. There are 3 basic logic gates: AND gate, OR gate, NOT gate. AND operation. The AND logic operation returns true only if either if its inputs are true. If either of the input is false, the output is also false. IC number. AND operation 74AC08N. Now turn on the next slide. OR operation. The OR logic operation returns true if either of its inputs are true. If all inputs are false, the output is also false. IC number for OR operation 74AC32N. NOT operation. The NOT logic operation returns true if its input is false and false if its input is true. IC number for NOT operation 74AC04N. Problem statement. A building has 4 floors that share the same water tank for water supply. To start the motor, each floor has a designated switch. First floor with switch A, second floor with switch B, third floor with switch C, and fourth floor with switch D. The motor only starts if any 2 of the floor switches are turned on at the same time. Motor start if someone press the switch from both first floor and third floor, or from second floor and third floor, or from third floor and fourth floor, or from first floor and fourth floor, or from first floor and second floor, or from second floor and fourth floor. Now I am inviting Mahawala Ibrahim to continue the present.
Thank you, Tarifuzzaman Ria, for giving me the floor. Hello everyone, this is MD Mahabub Ilahi Pradhan, and I am going to discuss about the apparatus, experimental procedure, truth table, sub and pos expressions, K-map, and Boolean expression. So let's start with the apparatus. We have used 4 pieces of OR gate. We have used 3 pieces of AND gate. We have also used necessary props or output indicators, and to do the simulation, we have used the simulation software called NI Multisim version 14.2. Now let's move on to the experimental procedure. First of all, we have developed our own problem statement. We found the inputs and outputs of the system and related the inputs with the outputs. We have developed a truth table for our system using the input and output relationships that we have established previously. We have generated a standard output expression, sub and pos expressions, K-map and K-map expression from the sub expression. And finally, we have simulated the circuit using the simplified Boolean expression and logic gates. Truth table. This is the truth table we have developed from the previously mentioned problem statement. Here A, B, C and D indicates the four floor switches of the building and Y indicates the output. As we have mentioned before, the motor only starts if any two of the floor switches are turned on at the same time. Here in the first condition we can see all of the four floor switches are turned off and the motor is turned off as well. And again we can see in the second condition that only one of the floor switch is turned on and the motor is turned off. But here in this condition you can see two of the floor switches are turned on at the same time and the motor starts perfectly. Here again we can see only one of the floor switches is turned on and the motor is off at that time. And again we can see here in this condition more than one of the floor switches are turned on at the same time and the motor runs perfectly. Now let's move on to the next slide. SOP and POS expressions and K-map. We have developed a SOP expression and a POS expression from the truth table that we have generated earlier, and from this SOP expression we have also generated the K-map as well. Each of the minterm of the SOP expression is expressed by 1 in the K-map. Boolean expression from K-map. By solving the K-map, we have developed a more simpler Boolean expression for our system, and by using this expression, we have developed a circuit for our system. We have used 4 OR gates, 3 AND gates, and an output indicator to complete the circuit. And the complete circuit looks like this. And this is all from my part. And now I am inviting the last of our group member, Sakib bin Mizan, to continue with the rest of the presentation. Thank you, everyone.
Thank you, Mahabub. Hello, everyone. I am Sakib bin Mijan from Electrical and Electronics Engineering Department, and I'll be describing the rest of this presentation. We used NI Multisim software to run this experiment, and here's some snapshot of this experiment. In the left-hand side picture, we can see the A, B, C, and D are the 4 switches of 4 floors, which have combined one output. Where we can see switch A, B are turned on and C and D are turned off, and as far as our condition the output is high. On the right hand side picture we can see the switch B and switch C are turned on and the switch A or D are turned off and the output is high. Here is the left hand side picture is the attempt number 3. Here we can see only switch B is turned on and the left and the rest of them are turned off, and as far as our condition the output is low. In the right hand side we can see only switch A is turned off and the rest of them are turned on, and as we can see the result is high. Let's analyze the results. The logic circuit was implemented perfectly. The LEDs were working only when the input values were high according to the conditions. The motor only turns on when any two of the 4 floors switches are turned on at the same time. No specific floor can turn on the motor at the same time according to their need. There must be another floor switch which needs to be turned on in order to run the motor. So let's discuss about our presentation. All the logic gates were implemented carefully according to the conditions we have mentioned in the problem statement. The simulation results and the truth tables match perfectly. Every part of was done with precautions. Despite of some common human blunders, we have acquired our expected outputs from this experiment. So we can say this experiment is successful. In the concluding point, we can say the combinational logic circuit that is designed by us work perfectly. This system has a few advantages as well. Water will not go to waste in this system. If any kid or anyone from any floor turns on the motor switch accidentally, the motor won't start. This system saves energy and power also, as 2 floors can use the water as their need. To sum up, we can say our experiment is successful. These are the references from where we have collected all of our data. So thank you everyone for sticking with us and listening to our presentation. Thank you so much.